So in our last notes, we talked about neutralization reactions. And in those notes, we were dealing with a situation where our moles of acid were equal to our moles of base. This time, we're going to be talking about limiting reactants and excess reactants and how that affects pH calculations within a neutralization reaction. So, hence the excess acids and bases. So, the pH of a neutralization reaction is determined by the excess reactant when there is an excess reactant. So, I'm going to go through an example calculation to figure out how to do this. And so when 25 milliliters of 2 molar H2SO4 is combined with 15 milliliters of 3 molar NaOH, determine if the solution is acidic, basic, or neutral, and calculate the pH. So the first step is to calculate the moles of the substances. So again, we're going to do our acids and our bases. So I'm going to underline everything for the acid in red. So our acid is H2SO4, and we have 25 milliliters of it, and it's 2 molar. So we have moles of acid. Remember, we take our molarity, which is 2.0 molar, times our volume, which is 25 milliliters, times our number of acidic protons, and in this case it is 2. And then we're going to do the same thing for our base. So I'm going to underline everything for our base in blue. So our base is the NaOH, and we have 15 milliliters of it, and it's 3 molar. So our moles of base, our molarity is 3.0 molar. Our volume is 15 milliliters. And our number of hydroxides is 1. So if we crunch these numbers, we get 45, and this is millimoles, because remember that this is moles over liters, and then for our acid, we end up with 100 millimoles. And that's just a 1/1000th of a mole. And then we're going to go back to the black pen. Alright, so that we calculated the moles of the substances. Now we need to find the excess reactant. So the excess reactant, because we know that these react because we know that the hydrogens and the hydroxides react in a 1-to-1 mole ratio in order to form water in our salt, we can just tell by knowing our millimoles what is our excess reactant. It's obvious, it's the one that has more. So in this case, our acid is our excess reactant. So we're going to take, so we'll have excess acid, which means that our solution is going to be acidic. So, and the excess acid that we have is 100 millimoles minus 45 millimoles. And that is equal to 55 millimoles of H+. So we found that. Then calculate the new molarity. The reason we need to calculate a new molarity is because we've added volumes. When we've mixed these two things together, we've diluted the total solution, so we need to calculate a new molarity. So we divide this by our total volume, so that is 15 plus 25, so that's 40 milliliters. Now our millis cancel out, and we're left with molarity. So when we calculate that out, we should get 1.38 molar H+. So we calculated the new molarity, and then we use the molarity to calculate the pH or pOH. In this case, we are asked for pH, and we have our hydrogen ion concentration. So we know that pH equals the log of our H plus concentration. In this case, it's 1.38. And we do that, we get negative 0.14. And yes, you can have a negative pH. That means that the concentration of the acid is greater than 1 molar. And you can also have a pH above 14, which means that the concentration of the base is above 1 molar. So if we had an opposite situation of where the base was in excess, so if base is in excess, then you use the OH minus to find POH, then calculate pH from there. So you just have to be careful about what it's asking for and what substance you are working with. Hopefully this will get you guys through your homework, and good luck.